Hey everyone, I am Jitesh.
Hello, I'm Soumya and we have our full team today with us.
Hey, I'm Rashmi.
Hi, I'm Roshna.
I'm Saurabh.
Hey, Shreya here, and we'll be discussing our project Arthritis Activity Manager.
The link to this video presentation will be available here.
Arthritis refers to the inflammation, swelling, and pain of joints. This project will be focusing on arthritis related to knee and feet joints. Our application aims to help patients understand the factors that cause pain. It tracks four of the major factors that are temperature, humidity, sleep, and step counts. Data are collected from multiple sources such as Fire, Dark Sky, and Google Fit. These data are collected and analyzed to provide visualizations to help the user better understand arthritis.
We distributed the tasks based on each of our skills and balanced the workload. We have tried to put up all the roles in a table here and assigning against them.
Coming to the team roles and individual contributions, Jitesh was the project manager who was responsible for the sprint deliverables, removing roadblocks in the project by communication, facilitation, and mediation, and ensuring that the release deadlines were met on time. He also helped in the weather API research. Rashmi was the front-end developer who contributed in creating wireframes for the app, developed the basic screens for the app, and integrated the fitness API to display the graphs. She also added the login module. Roshna, that is me, I was the backend developer who integrated the CI/CD pipeline with Drone for the entire project, helped in co-designing the database, designed the API contracts, and implemented a web service for all the API endpoints, and created data access layer for read and write operations for the patient's endpoint. Saurabh was the front-end developer who helped in the UI design and updated all the charts to include more details. He also integrated weather APIs and fixed critical performance issues. Srilada was the backend developer who co-designed the database, created it, and published it to SQL Azure. She created a generic data access layer for all the database call and also created data access layer for read and write operations for pain, sleep, and step endpoints. She also integrated FHIR to backend. Soumya was a QA developer who found issues and tracked them till they were all fixed in the application. She wrote automated test cases for backend APIs, worked on fitness tracker APIs for the integration, and helped Jitesh in sprint deliverables.
According to the CDC, in the USA, 23% of adults have arthritis. It is the leading cause of work disability and it usually occurs with chronic diseases. There are more than 100 types of arthritis with different causes and treatment methods. The pain level caused by arthritis depends on various factors, and we still do not have a single application to track the pain along with integrations and also to provide a correlation between different factors. The various applications that help patients with arthritis are as shown in the slide, but none of them provide an automated data feed to the system through fitness trackers. Reading data such as gender, age, weight, and the type of arthritis helps the application to provide personalization for the user. We also provide visualizations such as pain versus factors that help the patient understand the pain better. We interviewed three people, Ramachandran GV, Ashish Dwivedi, and Kavita Radhakrishnan, about their requirements for applications tracking arthritis. They mentioned that there was no one-stop solution to track the pain level with factors like climate, steps, etc., and that they required auto data population to the application using devices that they already use, and that they need a recommendation system to give suggestions to reduce the pain in a given condition. Seeing this, seeing this need, we have created a working prototype deployed in the form of a web application to solve the problem.
This is the login page of the application. I will log in as the user Sushma Pillai. The dashboard page gives the overview of the current week in terms of line charts, displaying factors of consequence to the patient. The first graph you see is a patient summary for the week. Pain level shown on the y-axis varies from none, meaning no pain, all the way to very high. A value of 0 denotes that the pain data for that date wasn't present. Pain value is supposed to be input from the patient, as we'll see later. The second graph is the activity summary in terms of step count. The step count values are fetched automatically from a fitness tracker that the user has integrated with the application. The third graph on the bottom left is total daily sleep duration. Sleep data like step count data is fetched automatically from a fitness tracker. The graph on dashboard aren't intended to serve as tools to help a patient draw any conclusions. They serve the purpose of helping a patient track his or her pain levels, activity, and sleep for the week. Next, we come to the activity page. Here, the user can view or update daily values for the pain, activity, and sleep duration. The first section on this page is for the pain input level. Current pain value for the given date is depicted by the position of the slider. The user can drag the slider to either enter a value or update an existing one. The user can also select a different date and add or update a past pain value. The next two sections display the activity and the sleep data values. Since they are automatically fetched from fitness trackers, the application doesn't provide the option to update them. The user can go at any point in the past to view the activity or sleep duration information. I now pass the control to Rashmi.
Saurabh, here in the factors page, it displays the correlation between the patient's pain level and different factors such as temperature, humidity, sleep activity, and fitness activity. This helps the user visualize and analyze how these different factors affect his or her pain level. The factors such as temperature and humidity correspond to the location of the user as mentioned in the FHIR patient record. Here in the graphs, the y-axis represents the 5 different pain levels and the x-axis represents the factors such as temperature in degrees Celsius, humidity in terms of percentage, fitness in terms of number of steps per day, and sleep in minutes. All the factors representing the x-axis is displayed in the ascending order to help the user analyze his pain level. With respect to increasing weather and activity data, by default, the page displays the patient data corresponding to the last 7 days. The user can also analyze the data from previous week or from a different week by changing the date in the day figure provided above the graph. Next, the profile page. The profile page displays the patient information. All the information displayed here is retrieved from the FHIR. The page displays patient information such as name, date of birth, gender, weight, condition type, such as a knee or a feet arthritis, location, and a link to the patient's FHIR record, which we will see in detail in the next slide.
When the new user is created in the Arthritis Activity Manager, it creates a patient record with observation and FHIR first, and then stores the patient ID from FHIR backward backend DB. The FHIR patient URL with ID is displayed in the UI, as you saw earlier, which on click fetches the information from FHIR and displays as we see on the screen. So we have a about link as well on the right top corner, which talks about the application of various pages like dashboard page, activity page, factors page, and the profile page. And the user can log out of their session by clicking the log out button on the top right corner of the screen.
The application features that were planned are completed, tested, and deployed successfully. Here is the Gantt chart for that. The Gantt chart shows that we divided into 3 phases and it was divided into 10 sprints, and this is a deliverable for a 10 sprint here. Here are the future plans and opportunities for this project. We can have integration for more fitness tracking devices like Fitbit and iWatch. We can provide APIs to third parties to do integration on their platform like Google Health. Additional features to handle more user and updating the information FHIR can be done. Some improvements on UI part can be done to be more illustrative with the charts. More type of arthritis can be handled when deploying the application on a commercial level. Making the app available as a mobile app too can be another task. Thank you.
Thank you.